then we'll share the recording with others, right? So this basically is an attempt to demystify the CISSP domain 3. So what happens is, most of the times, in my experience, I've been tutoring professionals for all 3 years now. And what I have seen is generally people give up during your domain 3. So they find domain 3 as something which is the point of where they give up generally, right? And it is because that domain becomes slightly technical, wherein you have to understand different kind of systems and then, try to get all that information inside your head. So it's very important that you understand how to approach domain 3, right? And that is my endeavor today, to how to approach domain 3, because you need to understand certain basic concepts before you approach domain 3, right? So domain 3 is all about security, architecture, and engineering. Now, once we say security, architecture, and engineering, how do you actually architect security is one of the main aims, and how systems are engineered to prevent anything wrong going to them, or how it affects the CIA of the systems. Now, once we say systems, there are multiple systems. There are mobile devices, computing systems, okay, operating systems. So everything is a system on its own. But if you follow certain simple concepts, then it becomes easier to tackle domain 3, right? Now, first, that's why I've divided this into only 4 heads, right? So, and it's very good mechanism if you can handle things the mind mapping way. Now, mind mapping is something which is the way our brains are wired, and we understand better if we follow the mind mapping technique, right? So the domain 3 has been divided broadly into 4 parts. And first part, if you look at, is cryptography. Now, what happens before we go to specifics? One thing I would like to tell you about how to tackle information systems. Now, information systems are based on subjects accessing objects. Right? Now, think of subjects and objects as anything, right? If you are going to open a door, who's the subject? Subject is you are the subject. And what is the object? The door is the object. So in information systems also, generally, the object is a data, right? Generally, it is data. And subjects acts on, does something, some activity, some kind of an operation on data, which is the object, right? First, you have to have that very, very clear understanding. Now, if subject is generally the active entity, subject is someone with whom activity is involved. If you are going to open the door, you are the person who walked, came near the door and opened it. Object is there, object is lying there. Now, when you build some kind of a control, some kind of a stoppage between how subject accesses an object, that becomes an access control. Okay, and how you manage this access control is all about domain 3. This is the first basic concept that you need to understand before you tackle domain 3 of CISSP, right? So now let's go further and mind map it. So now, if the access control is the one who controls how subjects accesses an object, these are the design principles or objectives of domain 3, how to engineer that, right? Now, the first part is, if you look at cryptography. So now, cryptography, where is cryptography involved? Cryptography is involved when how cryptography is actually a control, right? And how you engineer cryptography between subject and object is what the cryptography function deals with. Now, cryptography is of 2 types. Okay, one is symmetric and one is asymmetric. What is symmetric? Symmetric cryptography is when you have a single key with which you can lock or unlock a encrypted data, right? And asymmetric cryptography is you use 2 keys, public and private keys, to manage the encryption function. Okay, and that is how it goes into further details in domain 3 as to how to tackle cryptography. Okay, now this is where security design principles you have to understand. Now, when you say secure design principles, that means that you have to understand the concept of subject and object, which I already told you. Now, subjects and objects, the moment you have a subject and an object, now we said there's some control gap in between. There's some control in between, right? Now, what happens is, once we talk of security design, systems, okay, systems control, system is basically all three: subject, control, and object. And now if you have to create a system, if system is going to fail or system is going to go into some security matter, how does it fail? Does it fail and make the system insecure? Or does the system go into a secure mode? Okay, so these are the two basic architectures. Once the system you are designing, if there is some problem in the system, say you are in a room and there is a small fire, okay, does the door automatically close down? Okay, because if it closes down, people who are inside that room will probably asphyxiate and die. So that means in a system where subject and objects are residing, and if there is a failure, ideally doors should open out, alarms should ring up, and somebody should come to safeguard you. So the system should fail openly, right? System should not fail secure. But imagine a system where somebody is attacking a system of data which is not encrypted. The system should fail secure. It should secure the data and should not fail into an open state where the hacker is able to steal the data. So this is broadly how you need to understand the design principle, right? Then that is why you can say that system is failing into a secure mode or system is failing into an open mode. And that's where the concepts of closed system and open systems come in. Closed systems, what is a closed system? Okay, if I am Apple, look at Apple. Apple is a closed system. What does it do? It makes a software, okay, and you don't have access to the source code, okay? Whereas you look at Linux, Linux give you access to the source code. Which one is secure? Is Linux more secure or Apple more secure? It's a debatable question. But what happens is, in the world of security, open systems are supposedly, once you say that systems are more open, they're considered to be more secure because you can scrutinize the backend architecture, backend, code that is running that particular system. So there's always a debate between closed systems and open systems. Systems should always fail into a secure default. Okay, if there is a problem in a system and it is failing, it should always go into a secure mode. So once you are designing a system and you are designing a system when it might fail, then you should design that system in a manner that it should fail into a secure state, and after that it gets sandboxed. That is generally how systems are designed. And then systems have to be designed in a simple manner. Simple systems are much more easy to diagnose and easy to remediate, right? And now the concept of zero trust has come, wherein you say whenever a subject is trying to access an object, there should be no trust. There should be zero trust. That means whenever I'm going to open the door, I need to verify myself that I am authorized to open the door. Now imagine today, if we have to access any system, any process has to access data, it should authenticate itself before it accesses that particular piece of data. But now, if you have to implement zero trust, what happens? You have to implement access control between every action between a subject and an object. So whenever you are evaluating information systems, look at it from the point of who is the subject and what is the object and what is the control in between. Okay, and that gives you a broader understanding of how to tackle domain 3 of CISSP. Okay. Okay, so this was as far as secure design was concerned. It's a short understanding. But now what happens once you look at subject and object? Now there are certain security models which you can implement to get a secure design, right? That is the fundamental. So now once you say that if you have to design a system which has to be secure, then you need to understand that what kind of modeling we need to carry out. So that means if there is a subject which needs to access an object, you have certain models in between to engineer this control, right? And you can implement those models to secure how the subject accesses an object. So that is the fundamental of the security models. Now, there is something called a state machine model, and there's something called an information flow model. Now, what is a state machine model? Now, it's very difficult to read and understand what's a state machine model. But if you look at it, it's very simple. How? The state machine model says, if this is the data which you are going to access, what is its state? Is that data moving? Is that data static? If the subject has to access this data, what is the state of the subject? Is it moving? Is it active? Is it passive? Okay, so now evaluate. Okay, if there is a process which is running inside a CPU, right? And it has to pick up some data from the memory, right? So now who is the subject? The process is the subject. Who is the object? The data in the memory is the object. What is the state? The process of the state is executing. What is the process state of the data? It is static. Okay, so now what kind of control do you need to implement so that this process can easily access this data? That is what is defined by state machine model. What is the state of the data subject and what is the state of the object? Right. Then comes the information flow model. How to analyze subject and object based on information flow. Let's go to the same example where there's a process which is executing and there's data. So now information flow, if you see, information flow is happening from the data which is at rest into the process which is executing. So now if you have to implement a security control, you will probably implement a security control in such a manner that once the access is asked and the data is given, you need to design a control to control this information flow. And this flow will let you know how to implement a control between subject and object. Now, once you are a security architect or an engineer, why this is important is because at times you might have to analyze a system based on the state of the process and the state of the data. Or at times you have to see where is the data flowing, how to engineer this flow, where to put the control to manage this flow, right? And that's why it's called state machine model and information flow model. Okay. Then there's something called interference model and non-interference model. Interference model and non-interference model states that, say there is a process which is running, okay? There's a subject which is going to access an object, okay? And there's another subject which is trying to access the same object, okay? So now, if they are both going to access the same data, there might be some interference. And if there is some interference, this data might get corrupted. Okay, so you have to engineer the controls in a manner that this interference doesn't lead to data corruption. Now, let me give you an example for this interference model, right? Say, suppose you are doing a railway reservation, right? And there are some reservation, some ticketing reservation, and there is only one last ticket available. Okay, so June is also trying to book this ticket, and Shubhajit is also trying to book this ticket, both. Now, when both are trying to access this ticket, and both are doing the same process at the same time, what will happen? Okay, there is a concurrency issue which is arising now. So, if the system is not engineered in a way that it can handle both these subjects, this transaction might fail because two people are asking for the same data and it may not be able to. So what will happen is then you create a non-interference model. What? You generate two instances of this booking and they both execute. Whosoever executes first gets the ticket allotted, right? That is a solution. And this is how generally, database engineers, transaction developers, when they are engineering their systems, they do this. This is called concurrency control. That if there are two concurrent demands for a particular piece of data, how do you manage that? And that's why you make an image of both the data, let it access, whichever executes first, that transaction is allowed to be executed. There is a second way. What is the second way? If there is only one ticket, whosoever accesses this ticket first, they get a time window of say 15 minutes to execute the purchase of this ticket. If it is not executed in 15 minutes, this data is released and again you will find the seat is available. You will find this very common when you're booking a ticket on Indian Railways or you're booking a flight which is very, very, asked for. There's a huge demand and these are called concurrency controls. This is a very good example of interference and non-interference models. Okay. Now to make similarly, if you again have to differentiate subjects and objects in a way that integrity of the data is maintained, you use something called BIBA model. And if you have to maintain the confidentiality of the data, you use something called Bell-LaPadula model. Okay, very, very well-recognized models used in very, very highly secure environments. BIBA aligned towards integrity, Bell-LaPadula aligned towards confidentiality of information. And then finally is take grant model. Take grant model is a model which defines how subjects access a object. So if I have a right over a particular subject and I want my rights to be given to someone, then I give my rights. And that is how role-based access control systems are designed. Okay. So now if you want to learn domain 3, first understand very clearly what is the concept of subject and objects. If you understand that well, what will happen is you will understand the balance of the system well. And the last part of domain 3 deals with what is the capability of secure your information systems. And that's where it covers a lot of ground and it becomes very boring and you have to tackle it in a small bit. So you have to tackle domain 3's system security capabilities in a manner in which you understand. Pick up small chunks, don't pick up large chunks at one go. So firstly, you have to understand how hardware systems, they try to protect themselves. Then what are the computing components, RAM, SDRAM, how security is built around, memory aspects, how client-based systems, that are endpoints, engineer security, how server-based systems engineer security, what kind of industrial control systems are there, and what are the problems with industrial control systems and how to protect them. We also talk about virtualization and cloud in domain 3, how virtualization is implemented, what are the different kind of virtualizations, that is infrastructure as a service, platform as a service, and software as a service, and what are the security concerns, vulnerabilities, and how to protect them. Then you also talk a lot about mobile computing, wireless, and covert channels as to how those system has the capabilities to protect themselves. So that's why domain 3, slightly big domain and a slightly difficult domain for people who have not worked on multiple systems at a time. However, one thing I would like to tell you is don't tackle this domain in one go. Tackle this domain in a very short, chunks so that it becomes easier. Okay. This was just a brief introduction of how to, because most of the people try to, tackle domain 3 without understanding the concept of subjects and objects. If you understand the concept of subject and object and then put domain 3 between subject and object, that will become easier for you to understand domain 3. Okay. So with this, I've come to this broad introduction to domain 3 and how to tackle domain 3. If you have questions, please ask. My suggestion is please make mind maps for yourself. These mind maps help a lot because this is how you can have keywords and other things. You can keep building, whatever points they come, you can keep building for the exam. One of the best ways to study for CISSP exam. Yeah, any questions, please? You can unmute yourself and ask a question. So either you have not understood anything or maybe you have understood everything. I don't know. Yeah, any general question
Sir,
about CISSP?
sir, good evening.
Yeah.
This is Ravinder Kumar, and is there a order in this architecture engineering, like cryptography is kept first, then security design, then security models? Is this hierarchy or it is variable?
You can do it.
Understood, sir.
Okay, it's just I wanted to explain that. That's why. But yes, it's better to understand cryptography before you tackle it. But I personally covered cryptography in the end. It's personal choice. It's not related.
Thank you, sir.
Yeah, Dishu, any questions, any doubt? Or Atik? Yeah, I think somebody has chatted a question. Yeah, if anyone has any questions on CISSP also, they can also clarify. Yeah. Yeah, Jishu, please ask.
Good evening. Sorry, sir. Actually, I joined half of the in the middle, so I missed few things. That's the reason. Actually, I'm not going to ask anything.
Okay, we will load the recordings on our YouTube channel also. You can access that, right? That's not a problem. Okay, then thank you everyone for joining. We will keep having regular sessions and be on a lookout. And thank you everyone for joining. Okay, this for CISSP, I would like to tell that domain 3 is the only roadblock. Once you cross domain 3, it's a roll from there. So we just had a CISSP success few days back. Kaza Prasad, he passed within around 57 days to be exact. So the domain 3 is the roadblock. That is what I've understood from my previous students who have done it. Thank you so much and have a great day. Thanks for joining.